goal for today's lesson is to determine measures that provide optimization for area and perimeter. Okay, so a few different things here. Determining measures, in other words, the measurements of shapes, but we're talking about optimization of area and perimeter. So what they mean, first of all, about optimizing area and perimeter is a couple different things. So given a perimeter, a square has the maximum area. So when we want to optimize area, we're after the maximum area. And we know the maximum area is going to be a square. Also, given an area, a square has the minimum perimeter. So what we end up here when we're talking about optimization, the square is the ideal shape. It provides us both with the maximum area and the minimum perimeter. So let's look at our first example. I'll just get rid of that. And it says, what are the dimensions of a rectangle with perimeter 20 meters and a maximum area, and what is that area? So the first thing we need to remember is the part that I start, and that was the maximum is a square. So the first thing I'm going to do is I'm just going to very quickly draw a square. Okay, we know that a square, all sides are equal to each other, and a lot of cases too, we just give S as being our side length for a square. So what we're talking about here is perimeter and area. So let's talk about the perimeter and area of a square. So first of all, if we talk about the perimeter, we know that perimeter is the distance around an object. So in this case, it's going to be 4 S's. We also have been told that the perimeter must be 20 meters. So I'm going to substitute where the P is for perimeter with the number 20, and I can solve for S. So now we're going to divide both sides by 4, and we end up with 5 equals our S. Okay, so we've actually answered part of this question. Now what we need to do is they talk about area. Well, this is going to be my side length that we calculated. So then my area, and I'll just put it beside here, my area on a square would be length times width, but they're both the same, so S squared. And we calculated S as being 5, so we end up with 5 squared, which is 25. So all we need to do now is to actually write a therefore. So therefore, dimensions will be a square with side length 5 meters, creating an area move this down, area of 25 meters squared. So this is important in the sense that if you're given the perimeter, you're going to divide it by 4 to find the side length, and then to find the maximum area, you're going to take that side length and square it. Okay, second example. What are the dimensions of a rectangle with area 45 meters squared and a minimum perimeter? And what is that minimum perimeter? So this time what they've done, instead of giving us the perimeter, they have given us the area. And again, we need to remember that that is going to be a square. Okay, so they've given us slightly different information. So we already know that when we're talking about this, that area equals, for a square, is going to be s squared. I'm going to substitute the area they gave me, which is 45, and that equals s squared. Now, to figure out for s, we need to take the square root of both sides, and we end up with approximately, when we take the square root of 45, it's going to be a decimal number because it isn't a perfect square, and it works out to be something like 6.71. Okay, and that's an approximate number. Now, if this is what my side length is, okay, for my square, now I can determine the perimeter, the actual perimeter. So the perimeter, remember, in a square is the distance all the way around. So we have 4 s's, and we calculated s from above, which was 6.71. We bring out our calculator again, and we end up with 26.84. And finally, to finish it off, we need to put a therefore statement. Therefore, dimensions are, for a square, with side length six 0.71, and I believe it was meters, with a perimeter of 26.84. Sorry, my cursor doesn't want to go in where I want it. 84 meters. Okay, so what we've done so far, remember, everything has to do with a square. Square creates the maximum area and also creates the minimum perimeter, so that optimizes area and perimeter. Okay, now what we did today was when there were no restrictions, and the next part of the lesson is when there are restrictions on what they want for side lengths.